But I'll fly through this pretty fast, and it's kind of like we're really putting this out there in terms of some key issues we think need to be addressed in terms of soil information, and what are we starting to focus on in terms of what we think are major drivers. And you'll all be aware, this comes out of Irrigation New Zealand, it's on their website. They had a report done in terms of requirements by regional councils that they're expecting for the irrigation schemes throughout New Zealand over the coming years. You can see all about limits, nitrogen caps, phosphorus caps and things like that, so there's a big driver through there. And the other key thing will be these farm environment plans. So actually farmers producing management plans about best practice on their farms, and they're expecting that again out of most councils. The key thing is what they're expecting is that that'll be different in different councils, different environments. There'll be different regulations and things like that. So that's a key driver coming through to us. It's not a one rule fits all kind of landscape. We're moving in scale, I guess. And so this really, and we've talked about this, I mean, that's what we were just talking about before. For us, it's a game changer in that our soil information is becoming increasingly linked to policy and regulation. So they're key drivers, and that has big implications for us and the type of science we do, the expectations of the information. And so, again, we reinforce this point. The success of these really relies on quality soil information. And so there's ample evidence which has shown that. We've done case studies and things like that, and we've talked about the work we're going to start doing in terms of uncertainty and the impact of soil information on some of these drivers. So to get this quality soil information, what does that mean? It's really the provision of this information. It really needs to have clarity, certainty, auditability and consistency. And this is really important because at the regional kind of level, it's been a single agency, Landcare, that has produced a lot of soil information together with regional councils and that kind of side of things. This next stage that we're going to with these farm environment plans is we're going to moving down the focus on the farms and sub-catchment within catchments. That's going to be multi-agency kind of like information providers there, and irrigation schemes might want to have to do their own way. We see Beef and Lambs wanting to produce its ones. Frontier is doing its different irrigation schemes, and councils and support agencies like us, we'll deal with information coming from multiple different sources. So for that to work, then the key thing is it needs to be able to link not just the farm but to the catchment outcome. The farms don't sit within isolation, they're related to a catchment outcome or a regional outcome of some sort. So that's why this word consistency comes into it. We need to be able to allow integration across these scales from the farm data all the way up to catchment level monitoring. It's not much point if all the farms are all done in all randomly different ways and then someone says, well, what's the impact on the catchment? And we try and pull that together and we can't do it because the data's, it's just not compatible. And we've had cases of that elsewhere that have happened within the country there. So, and it needs auditability, as everyone will know. It needs to be auditable. People need to be able to have confidence in the information and how it's been collected and that kind of side of things. And for those people that are investing, they need to have clarity in terms of the appropriate methods and options for farm scale mapping. They need to have a good, clear understanding of what's suitable, what's not suitable, what's going to be accepted, what's not, and certainty in terms of the accuracy, reliability and acceptability of the data. So they need to have confidence to spend money because it's not cheap. There's a whole range of sources of soil information, and I could fill up 3 different pages, we won't go through it, but basically there's various methods, multiple methods by which people will generate soil information. So what we've been pushing is a national set of standards and protocols for the provision of soil information within New Zealand. We think it needs to be simple. It doesn't need to be complicated. It needs to be underpinned by reference standards, and it needs to be able to produce consistent and auditable outcomes. So there's plenty of reference standards within the literature and out there within there. People just need to have easy access to them, be able to know when they're suitable, when they're not suitable. It needs to be different in key land environments. So the stuff on the plains, a lot more detail, a lot more complexity than the hill country in the North Island or the steep mountain lands up in the Alps up there. And it needs to be flexible to accommodate new issues, new science and new technology. So it can't be set in stone and set in rock. An example, a little bit complicated, but basically what we're proposing is there'll be 4 kind of quality levels for soil information, provision of soil information. Poor, what we'd recommend probably shouldn't be linked to policies. But then councils, industry agencies, on that kind of side of things would most likely probably be selecting basic and good as their standard kind of like quality levels that they recommend. And premium is really targeted for where you've got an intensive land use and a highly sensitive kind of catchment. Industrial waste being deposited on a stony soil somewhere near the Christchurch aquifers, for example. I'm not quite certain. That's, again, not for us to decide. It's up for industry and people to decide. There's different types of soil information that need to be provided there. There's a soil map, so again, that's spatial variation of soils. And then there's basic attribute information that's needed to run various models and on that kind of side of things. So at the basic level is what we're all kind of working at the moment is SMAP Online linked to the SMAP fact sheets. Together we're, in terms of, sorry, I forgot to add this in, temporal dynamic attributes is the other set of information, which is things like the dynamics of, for irrigation scheduling, water, soil water fertility testing, soil structural integrity and under compaction or non-compaction, things like that, stuff that can change, seasonally and under different managements. So those are the three types of information. Variability of the soil, basic soil data attributes, so your key water holding capacity, stone content, drainage of the soil, some things which are quite hard to change. And then the temporary dynamic things that can change quite rapidly, which might require more detailed on-farm monitoring. So at that basic level, we're targeting the integration of a lot of tools with SMAP Online, the fact sheets, on-farm observations for these temporary dynamic attributes to get all otherwise model defaults, as in the case what occurs with an overseer, and that's freely available. So that's a base level information for everybody that we should be targeting and going. Ideally, over time, we'd want to move towards the good level and through here, which is in low variability landscapes, the Lismore surface we've got out here, there isn't a huge variability in soil types out there. But some areas there are high variability, and I'll show you in a second where there is. We might want to do more targeted on-farm mapping. So detailed on-farm mapping, go through and do some observations. You could get the base attributes by linking this detailed farm mapping. I'll show you an example in a second with SMAP fact sheets. Or you might want to do on-farm data, dig pits, and I'll talk about that in a second. And temporary dynamic attributes should be doing on-farm measurements. That comes at a cost. $10,000, $15,000. It's not cheap to provide on-farm soil attributes. If at the premium level, which is the type of stuff we do for some of these resource consents, we do detailed on-farm paddock mapping, link to the SMAP fact sheets, remember linking back to the NSD, but typically we're digging pits, we're measuring attributes on the farm through there. So a lot of the precision ag work that we've done, which I'll show you in a second, is done at this kind of like level. Again, industrial waste disposal. You don't get much change out of $10,000 for a 200 hectare farm. It's not a cheap exercise to do. You want to have confidence and clarity and certainty that when you spent that money, you're getting the right data that you need. So an example here, the Great Farm Scale Challenge. A centre pivot, irrigated dairy, you've got a floodplain, a river over here, low terrace, jump up onto the surface up there. We've done some detailed mapping, mapped some different polygons, different combinations of soils. Down here in the red zone, right down low, we've got really young stony sand soils, like we talked about just before in the previous slide through there. Jump up onto the terrace, you've got stony soils up here, but these are the older stony soils. They've got a lot more silt amongst them, clay in amongst them, quite a different beast to this one down here. Can't see that so well here, but basically you've got another soil which has got, say, 50, 60, 80 centimetres of silt over the gravels. Come into the back of the terrace, poorly drained soil, high water table, stone free though, high clay content. Jump down into the bottom back of the floodplain, you've got a really young stony sand soil, but a high groundwater table, so poorly drained in the back there. You've got two options once you've mapped that, is one or three options. You guess in terms of key soil attributes in there, so you get Sam's opinion, we pick someone else, they'll have their opinion, someone else, they'll have their opinion, they'll link to other methods around the place, all can end up with very different information. So that's option one, which people can do. Option two is you dig the soil pits here, characterise them in a standard way, following a kind of protocol what we talked about before. You're able to, quite cheap, because this involves you digging a hole and looking at soil attributes, link that to the SMAP inference engine and the fact sheets, and you can pull out all of that modelled information, all the uncertainty, link straight through to the tools, feed through to different end users. People have got clarity about where it's come from, the uncertainties associated with things like that. Option three is you do what we've done in this situation here. You measure all those attributes there, around a few, $3,000, $5,000 per pit is what you'll be spending on getting that characterised, send it off to the labs on that kind of side of things. So the key thing is that these things will all have different water holding capacities. was on the farm. It's going to affect nitrate leaching, it'll affect phosphate leaching, it'll affect water irrigation scheduling. The reason we did this was for irrigation scheduling, and we were able to show the return, economic return from targeting irrigation onto here. So precision irrigation, the return was roughly in about 2 years for the investment of doing the mapping and also converting across to variable rate irrigation. So a very high economic return when it had linked to a specific outcome, simply by knowing the spatial variability and having confidence in the water holding capacities, being able to target that temporal monitoring into the right zones there and linking it to the right technology. So the option we're recommending as part of the protocol that can reduce the costs quite a lot is dig these pits, describe the soil, identify some key attributes there, be able to use the SMAP inference engine to identify the fact sheets, so the soil type within the fact sheets there, and you can generate a whole range of attributes through here, and we've done this in a number of cases, compared it against measured data on that kind of side of things. And what does this tell you? Well, it's linked to best management practices really. All of this information on this first page here is all linked to irrigation design, irrigation management. Here you've got 3 different, you can't read it, but water holding capacity at 3 different levels over a whole metre, 0 to 60 centimetres, which is the pasture irrigation people are really interested in that, and the top 30 centimetres, which is what the dairy shed effluent people are interested in, scheduling irrigation design for that. Here there's a whole lot of information around these vulnerabilities, identifying where good management practices can be targeted. On this case here and that, probably not much gain from targeting waterlogging vulnerability. It's a nice free draining kind of stony soil. But down here in terms of bypass flow, there is a medium risk of bypass flow, so that preferential flow we talked about before. Target best management practices towards that could give you a good return. And sitting underneath this, there's nitrate movement and things like that. Here we've got specific information here, targeting to a certain group in terms of the dairy shed effluent framework, what I talked about with the young stony soils before. So you're able to identify in terms of the pond storage calculator, the size of pond that you need for storage of effluent in that, from the fact sheet that's got the right information which feeds straight into that, that's able to run that model. And we showed before the whole third page for overseer, again, linking from that. Very hard to come up with that all completely off your back and have all the science that sits behind that. So what we recommend, this isn't a Landcare thing, we're throwing it out on the table. We're responsible for the characterisation of New Zealand soils and standard methods and things, but we think it should be a pan-agency, driven by, I'm not quite certain, councils, industry, and research sectors and universities as well. It's actually a very simple thing. It's not a really complicated thing to do. It's just getting people to agree together. A lot of it's all sitting there to be able to be done. Consistent New Zealand-wide training. We need to standardise how we train people in terms of basic soil descriptions and informations across universities, across industry training organisations, to make them be able to use the power of all of these support tools that we develop. For example, within New Zealand, there is, I know of at least 3 or 4 different soil description handbooks that people use, different ways that people describe things, different ways that people describe soil texture. That makes it really, really, really hard to get any kind of consistency and auditability in both how we support that from an information provider, but also in terms of model outcomes and things like that in use. There's no need for that within New Zealand there. Simple soil mapping tools, simple things, simple soil mapping and description guide. I haven't pulled our classic pedology one. I can pull it down here and we all get lost within the first 3 pages. It doesn't need to be that complicated. We can simplify that right down into photo guides and focus on key attributes. You know, how do you identify poor drainage? How do you identify whether there's stones in there or not? Photos of this is 10% stones, 30% stones, 70% stones. That kind of side of things. The online fact sheet builder, so how can we adapt our fact sheets within SMAP so that people can describe those simple attributes in the field, go onto online, enter in some key information and bring up the soil information that they need out of SMAP, link through the National Soils Database and all the tools and things like that. And we're recommending, Manawatu's already doing a lot of work in this kind of area, the farm scale stuff, so there's a lot we can all learn out of that. And Canterbury is in probably the Waikato, possibly Otago as well. I shouldn't say next cab's off the rank, but we're getting to this point where we're moving to the farm scale stuff, so there's some very easily done within here. So the key things is we're starting to focus on supporting farm scale soil information. We see that as the key driver, and again driven by linking of policy and regulation. Critical to this is a national protocol about the provision of soil information, collection of soil information and standard methods by which people can easily have confidence that what they've invested in is going to be right for the needs. And the big challenge is closing this consistency between the farm plans and the catchment outcomes. We don't want a whole lot of soil maps being done on all different types of farms that then make it very hard to quantify up to the impacts at that kind of larger scale. So I think that's the last rant as such. So any questions?